Okay, so this is just the landing page, or can say the dashboard. And this Wireshark basically is used to capture the packet. If I give you a little demonstration, let's suppose we have two computers. And it is sending some information to this computer. If the Wireshark is installed in this computer, on this interface, we can enable this Wireshark, and it will give us a lot nitty-gritty details about the packets or what is going on in our network. But make sure it is only going to give me information from this end.
Excuse me, Cameron, are you drawing something?
Is it not? Oh, sorry. Yes. Just a minute. Let me share. I don't know. I shared it, but why every time?
We are just looking at.
Okay, let me select these all things. Now it's okay. Can you see?
Yes, I mean, we don't see drawing, but we see the.
Sorry, very sorry for that. And thank you for pointing out. So I was giving the demonstration. Let's suppose we have two computer, PC1, and we have a PC2. Okay, and the Wireshark, if it is, this is kind of application, if it is installed on this computer, then if this computer is going to send some information to this computer, we can capture this all information on this interface. And it is going to give me all, as I said, the nitty-gritty details, what is happening in our network or what is happening on this network interface card. But we also have some other terms known as span and rspan, which is used in a Cisco. Because we are not bound only to this network interface card. What if we have one switch here and this computer is connected this, and then there is another computer that is connected here, and I am interested to capture the traffic for the other computer interface, then what? Then we will use span, which is switch port analyzer. Just don't worry about this. We will do a lot in detail in when we will hit the CCNA. But just for overview and just basic concept, we will use span. And then our span is, let's suppose we have multiple switches connected in a daisy chain fashion. And we want to capture whatever the traffic is going through this interface, network interface card, then what? We want to capture from this computer. So Wireshark is installed in this computer, and we want to capture the packet that is coming back and forth on this switch that is far away. Where we use this concept is called RSPAN, and R is stand for remote. Remote switch port analyzer. Okay, so this is just a flyby overview of Wireshark, what basically we used for. And I'm going to give you a demo. So basically we need to go into this capture, and we have to let me run this again. Sorry, just a minute. I will enable that one again.
That's the best background I've ever seen.
This is from my daughter. She loves these animals a lot.
Me too. I understand completely.
So can you see the Wireshark?
Yes.
Yep.
Okay, that's fine. So we have multiple network interface cards. Why? Because I am running some virtual machines on my computer. Then I have some wireless network adapters like This is my LAN, physical connectivity for the physical connection. Then this is wireless. So I have multiple network interface card, but you have an option to choose only one because you are going to analyze the packets only one interface. So in this example, I'm going to capture the packet from my LAN, which is basically connected to my access point. So you need to just click on this local area connection and double click on this one. And as you can see in the background, it is start to capturing the packets. And currently is UDP. Why? Because we are running this Zoom session. So that's why we have so many UDP sessions going on. So let's go to some website. Let me share. Let's go to some jobskillshare.org. And then when you will go back, you will see some TCP activity as well. So let's stop this capture from here. Just in a fraction of second, did you notice that how many packets we have captured so far? Almost 9,425 packets.
Oh, wow.
Okay, but you don't have to worry about because we can filter it out. Let's suppose if I am only interested in a TCP packet. So this is called the filter. Here, some specific commands we need to apply, but this is very simple. What we are looking for here, we are looking for the TCP. So type TCP and hit enter. So we are only hitting TCP. Not to confuse this TLS, this is transport layer secure, as it is mentioned here, transport layer security. It is using HTTPS 443. This is the port number for HTTPS. Since we are here, I'm going to mention HTTPS use 443 for secure connectivity. Means whatever, for example, if we are doing some kind of transaction on a bank, okay, obviously it is gonna happen using HTTPS protocol because it is secure. And what does secure means? Whatever the communication is gonna happen, it will be encrypted. If some, some rogue person or some evil person is sitting in the ISP, in the service provider, and try, because our all this data is going through where? The ISP. And someone is sitting in the ISP and he is capturing the packet, then what? He can get and hands on your all information like credit cards, or we do not want. So that's why we use HTTPS, which is secure. And opposed to HTTPS, we have HTTP, which works on 80, which is not secure. Okay. So here we are, and I just filtered TCP. And if I select some TCP packet like this one, it is going to give me some information like the number. What is the number of this packet? The time it hit to this packet. Before it was like this kind of millisecond, and the time when we received this packet, it was this time. Then this is the source. It is being sent from which source? And 192.168.100.3 is my computer IP address. So this is my machine. This is source. You can check from here. This is destination, where I'm heading to. This is 198.251. Some public IP. This is also called as public IP. This is also a very good interview question. They can ask, what is public IP? What is live IP? They all have similar name. Live IP and public IP both are same. It means you are going to somewhere, maybe this is job skill share server, which is running this public IP. It is using what kind of protocol? The TCP, which is secure. And currently it is giving me acknowledgement. But if I will show you, if you right click on this one, TCP, and go into the flow, TCP stream, click, just close this down. We don't need this one. And just come on the top of this, not this one, just again, you can do right click, go flow TCP stream. Actually, I'm going to show you those sync act. Okay, let me do it again. So I just erase my filter or remove the filter to return back the original dissolved packets where it is showing the TCP and UDP. So I need to come into the TCP packet. Let's suppose this one. Right click, go into follow and TCP stream. Because before, why that was the problem coming, because I was already filtered the TCP and then I was applying another filter. So it didn't work. As you can see, it went through some FIN packets, and this was already in my, basically, the conversation already happened. So that's why, if you notice there is a FIN packet, it means this is going to be your last packet. It is saying that my communication is going to finish. And we receive the acknowledgement. So this is called the TCP communication is happening. If you select this TCP, you can see we have some another nitty-gritty detail which has to do with your OSI layers. If you notice, just forget this one, the first one. Don't worry about this one. Ethernet, we know, works at which layer? Layer 2 layer. Layer 2. And we have to deal with MAC addresses. On Ethernet 2, you will find the MAC address information, source, and the destination. Okay, so this destination basically is my access point. This is the MAC address or the identification of my MAC address. We will talk about MAC address a lot in detail, so not to confuse, just get the concept of what is happening in the Wireshark. Then we have the next layer, which is IP, or the network layer, basically. It is giving me information that it is using IPv4 version. As you can see, IPv4, and the source is 192.168.100.3, which is my computer, and 192.168.100.3, which is basically the IP address of my access point. Okay, but actually I need to go into some another destination, which is some public IP. So this is how you are going to get the information, some nitty-gritty detail, what is happening inside your packets. If you want, I can expand more this one to take a lot of detail, which I do not want to, explain here right now, because you will be confused otherwise. Then we have another layer, which is called transport layer. And we have already learned in the OSI section. Transport layer works with what? TCP and UDP. And the ports. Okay, so if we expand this one, as you can see, we discussed about the TCP has some kind of sequencing, acknowledgement, windowing, everything. And you can notice here, we have sequencing, we have acknowledgement, we have pin packets, we have windowing. So just by looking at just this information, we can, we are clear enough that we are talking about the TCP here. The TCP is the protocol. TCP use source port and destination port, as I discussed earlier, from 0 to 65,535. If you want to see the information, you can see it is using source port, which is not well known. It is not well known because this is some kind of random. Because when you will learn about about the protocols numbers in detail, you will see this is not a well known port. On the other hand, the destination port is 443. And you are wise enough to understand this is HTTPS. Okay, so TCP is using, as I said, these kind of concepts plus ports numbers.
Now this is a great example to show you a visual, like how it just a simple packets flows through the network, and how engineers will just get in if there's something going on a big network level. Like let's say a help desk contacted you that it's not just one machine, it's every machine that is just having this issue with whatever it is, like specific, maybe they're not getting a full bandwidth or something like that, or some application is not behaving correctly inside that network, but it's behaving correctly outside of the network, like overall network. Or maybe it's not working correctly on one floor, because maybe that machines are connected to that one switch. You would be using tools such as Wireshark like this to break things down, because you need to really go into deep, like what's going on with these packets. Correct me if I'm wrong, Kamran. That's
Yes,
how
exactly.
you guys kind of get into, right?
And thank you very much. You just gave me an idea so I can give them the real scenario why basically we use the Wireshark in our production environment. So if just I filter out TCP, have you ever heard about one attack that is known as, if somebody can explain, what is this?
Isn't that when a lot of DOS attacks? Isn't that when a lot of packets are sent to a, I don't know if it's a machine or a network.
Yes, you're right.
To
you're
try
right.
to overcrowd it.
Exactly. This basically means if some server is running, basically it stands for denial of services, and the name suggests denying for something. Okay, let's suppose we have a Google server and we are trying to reach Google server, but sometimes have you come across with this situation that you are trying to access this server but it is not available?
Yes.
Yes, and that 99% of the time happened using the denial of services. And what denial of service is connected with is basically the TCP. The attacker is sending sync packets repeatedly, and the Google server is sending back sync at in reply. But our attacker is intelligent enough, or can say the evil enough, he's not using acknowledgement in the return. Okay, so just these things are being sent, sync at. This is how it is going to send millions and millions of packets in just a fraction of a second. just to avoid the services for the any server. So if some user is trying to connect, let's suppose he's trying to purchase some stuff from the Amazon services, but some attacker has attacked with the help of denial of services, the user cannot access Amazon server.
And that's a common thing that you're going to come across when companies don't have a solution for, DOS or DDoS. That's another thing.
Exactly.
So if you don't have that solutions to stop it, then you would be dealing with this type of issue as a network engineer. You're like, oh, yeah, our network is being hit by, so many sync attacks that our server just is exhausted, and I need to block an IP address. So you would go into, but of course we have more advanced tools to counter that. But Wireshark can then help you more, even like, okay, how many syncers are open at TCP?
Yes. And then you can notice in the destination that some, or from the source, that one particular source is sending this sync and sync packet frequently. This is how you're going to diagnose in a packet tracer there is something happening. Okay. Make
I'm
sense?
sorry, what's the difference between a DOS attack and a DDoS?
Okay. The DDoS, denial of services, basically when we have a single machine and we are trying to attack some another server from a single location or single device. But in case of DDoS, which is distributed denial of services, this is very like advanced concept, but no problem. We create the
you don't have to answer. We can go back to it in the future if it's too much.
Okay, that's fine. Just I'm giving you a little info, no problem, because Crystal can understand. She has a very good, mentality, and mashallah, she is great. So we have distributed denial of services, where we basically create these zombies, and we have multiple, these zombies in place, and that will basically act like evil machines, and they will also participate in denial of service attacks. Okay, and then we have multiple these zombies. We have multiple devices. They all will be attacking to the same server, which will make them DDoS. Make sense?
Got it. Thank you.
Okay.
Yeah, and this is something, if we will later on when it comes to troubleshooting our security sides of, because we're going to do another security session on. That's something we're going to cover a little more detail. Like we probably show you some third-party tools that are kind of these days modern tools that we use for stopping such things, or you'll be working as an engineer. So that's something we'll cover.
Okay, so we were talking about the TCP. Let's talk about the UDP. You have to do nothing, just replace TCP with the UDP and hit enter. So as we can see, we have the UDP packets. So just select any of the single packet. And this we have already discussed that this is layer 2, this is layer 3, but we are more specific to this user datagram protocol. As you can see, nothing is going on in UDP because this is fast. It has source port, it has destination port, and that's it, and some checksums. As opposed to the TCP, which has like sequencing, acknowledgement, windowing, and everything is happening in that. So that is one of the reasons this is fast, because nothing is going on inside the UDP. Okay. So this was the basic demonstration of TCP versus UDP. I hope you get it.
I get it. Thank you.
Yeah, that was a very good explanation.
Oh, thank you. So let's start again. The same thing that was happening, basically, I just demonstrated here. This client is sending a sync packet. It received, and it just sent back the sync at. It just sent back the sync at. the connection has been established at this moment. Now it sent back the final acknowledgement, so it can also establish. After that, the information will be sent.